every quadratic equation is always quadratic equation is always in form of as squared plus bs plus c equals to 0. Now, and here, if you solve for where x, that's if you solve for the answer, x is always from our quadratic formula is minus b plus or minus that. So if you look at this, the answer, there is one important term of this answer. Yes, it is this one, the one that's the one inside the square root. So why is it important? It's important because this determines, remember, the quadratic equation will always have two different roots. That's the plus and minus here. Has two answers. One is positive, that's taking the positive, while the other one taking the negative. So this determines the type of the roots that will be formed. Yes. So if you notice, if you check this, if b squared minus 4ac is 0. So if you plug in, if this expression is 0, you notice that the answer will have only one answer. Yes. If you plug in this, you see that we have the answer will now be minus b over 2a. But everybody here knows that the answer should be 2. So once it's 0, we have only one answer. So it implies that 2 answers you get will be the same thing. You get two answers, but those answers must be the same thing, since a quadratic equation must give us 2 answers. So, but if this is 0 now, it will seem that we've gotten one answer. Yes. If this is 0, we have only one answer, minus b over 2a. So that means the two answers are the same. So the two answers will coincide, become one. So instead of, remember, the solution of the quadratic graphical way of solving quadratic equation is the intercept, as the answers where the curve intersect the x-axis. So now it will just touch it at one point. That's the only condition for it, the two answers to be the same. So, and what? But if b squared minus 4ac is greater than 0. Yes. What is that the possibility of this expression? Either 0, greater than 0, or less than 0. So what's the meaning? So if it's a positive number, what do you observe? It will have two different answers. Yes. So the positive one and the negative of this. So this one means one answer, that is two the same answer. To the same, let's call it roots, to the same roots. So this one will have two different answers, meaning two different roots. So this one, why the last one Last condition if it's less than 0. So this one, if this is negative, and we know that square root of negative number, they are not defined. Yes. We can find the square root as in the real plane. So we're not talking about complex plane. So the square root of negative number is not defined. So though we know that a quadratic equation must have a root, so meaning no answer. This no answer means that no answer. This means that it will never intersect the x-axis here, because that's it. For it not to have an answer, it will not touch x-axis, or it won't cross x-axis. So now these are the three different types of root that a quadratic equation will form. So let's use a diagram so that you see. So you see it. So these are the diagram. So this one, the elements that will equal to 0. Okay, let's just change this. So assuming the answers are concave, we know quadratic is either concave up or concave down. So this first one is where b squared. This A is where b squared minus 4ac is equal to 0. As you can see, it intersects at only one point. Yes. So it's now tangent to the x-axis. The second one is the b, is where it has two different answers. So I told you this means two the same roots. So let's call it R1, R2. So they will coincide and become one, because it must have two roots. So why this one? Two different roots. So we normally call this one. So if once is equal to 0, it means real, and because it's a real root, means it has a root, real and equal. So anyone that touches the x-axis at only one point will have real and equal roots. Why this one is real? Real means it has a root and different roots and distinct. So this is 1b squared minus 4ac is greater than 0. So that's the b. Why the c part is 1b squared minus 4ac is less than 0. Like I said, no answer, no root. See how it's hanging. I will use an app so that you see it. So this is called, though it must have a root, but in real life is no root, so we'll call it imaginary or complex roots. Imaginary roots, or you call it complex, because of this square root of negative number. So that's it. So these are the three types of root that will be formed. Every quadratic equation must be intersect the x-axis at only one point, at two different points, or no intersection. Let's find the type of root of the following quadratic equation. So let's see whether it's real and equal, or real and distant or imaginary root. So the first thing is to look out for the discriminant. Yes. So I've told you that's the determinant, the major determinant, the discriminant. Squared minus 4 is, so that's what determines the type that will be formed. So the first one, so A is what? A is 3, B is 2, and C is 1. So now let's get our B squared minus 4A. So B squared is, that's 2 squared minus 4 times 3 minus 1. As you can see, this is 4 minus 12, which is minus 10. So this is less than 0. So the root that will be formed here is imaginary roots. So it will never intersect. After we use our plot it, we plot it, you see, by using that now. So the second one, A is what? B is 1 and C is minus 3. So let's check. So if you now do B squared, which is 1 squared, minus 4 times half, that's minus 3. So we see that 1 negative times negative positive. So this, to give us a positive answer, yes, it should be greater than 0. So it will be real, since it's positive, as distant. This one will intersect in 2 different places. Why the last one is, let's look at the last one. So our A here is 1, our B is 4, and our C is 4. Therefore, if we do B squared, which is 4 squared, minus 4 times 1 times 4. So what it is, 4 squared minus 4 squared, which is equal to 0. So we now have imaginary, real and equal. To just touch the x-axis at only one. So let's plot this so that you see that we are correct. See this interspace. So let's plot. Let's see. So the first one is what? 3x squared plus 2x plus 1 equal to 0. Well, to remember is the curve, then the x-axis once it intersects, so we're equal to 3x squared plus 2x plus 1. So what do you observe? Yes. Remember, the solution of solution of quadratic by graph is the intersection of the curve. So see the curve. See the curve. You see the curve. Why the x-axis is y equal to 0. Right? Y equal to 0. So no intersection. Yes. Y equal to 0 is the x-axis. So do you see the curve didn't touch or intersect the x-axis? That's why it's imaginary. This is imaginary. It's not touching. So if you check the second one, let's do the second one. The second one is okay, half x squared plus x minus 3 equal to 0. Half x squared plus x minus 3. Half x squared x squared plus x minus 3 x minus 3. So what do you observe? Are you seeing it? You see that it's intersected. See, yeah, it's intersected at this point, at this point. So they see the answer minus 3.65 and 1 point. So do you see real and distance? I see it different. So watch the thing now. You see that B. You see, it has only one answer, the same answer. Two the same answer that coincides. That's why this A is no more there. You see? So, which is correct? Real and equal. Let's see the diagram, real and equal. So now, let's solve this final question. It said, for what range of values of P does these have imaginary roots? So it's a tricky one. Let's see how it goes. So for a quadratic equation to have real imaginary root, b squared minus 4ac must be less than 0. Yes. And from here, what is b? B is p. And we're looking for the values of p. So I have b squared minus 4 times 4 and c is 1 less than 0. So this is now p squared minus 4 squared is less than 0. And this difference of 2 squared, which is p plus 4, p minus 4 is less than 0. So now, if I solve this, because what I will solve, you might not get it. This is what we call quadratic inequality. Yes. So let's look at quadratic inequality. So any quadratic inequality is now when a squared plus bs plus c either less than 0 or greater than 0 or less than or equal to 0 or greater. So this is a quadratic inequality. And to solve it, it's somehow different from the way we solve quadratic equation. This one is now inequality. And let's use our common sense. You know, when quadratic equation is when a squared plus bs plus c is equal to 0. And this must have two answers, right? So assuming the answers are R1 and R2, where R1 is less than R2. So one must be less than that for it to have to different roots. So even if they are not at the same, no problem. But let's assume that one is greater than the other. So R1 and R2 are the two values that if you substitute here, x, that's the x values, it will give us 0. So these are the two numbers that will give the answer 0 in this word. Yes. Others. So other numbers, once you put it here, it will be either less than or greater than 0. Yes. And common sense will tell us for us to get the two answers will be easier. Yeah, because I have only two answers that will give us equal to 0, but billions of answers that will give us either less than or greater than 0. So how do you solve it? We solve first as if we are solving quadratic equation to get the two answers that are the ones that will give us 0. So aside these ones, aside this and this, the answers will be less than or equal to 0, meaning numbers that are less than the smaller one. Yes. So we have three categories of numbers now. So the ones that are less than the smaller one, the ones between the two, or the ones greater than the greater one. Yes. So aside these two, these ones will give us 0. Other numbers that are either numbers that are less than this small one, or numbers that are between the two, or numbers that are greater than this one, will now give us greater than or less than 0. So it depends on the question they give you. So formally we'll prepare a table. Yes. So how do you do it? The formal, but if it's OBJ, you don't need to waste time here. So you prepare a table as I solve, such that this is the interval. The first one is the interval. So the interval, will have 3 intervals here. Yes, numbers less than the smaller one. So when x is less than R1, numbers between the two, which is numbers between R1 and R2. Finally, numbers greater than so these are the answers. So it will fall within this range. So how do we now test? Yes. How do you test? You test by factoring. In quadratic function, this will always be factored that maybe as plus a1, something like this, maybe b, something like that, a2x plus b1, b2. So yes, you have to factor it. Or if you solve by quadratic, let's assume it's factorizable. So that's it. So you now have a1x plus b1, a1x plus a1 is a2, b2. So we'll test the values here. If you put it, the values of x, the inside interval, you put it in both of this and this to know whether it will give us negative, positive. So anyone that's satisfied, that's the meaning of this. So if you pick a number here and substitute here to know whether it will be less than or greater than 0. So if it's less than, it depends on this. That means the answers, the range, the numbers within that range is now the solution. Yes. Because this final, this is the product of this and this. This final row here, this is the product of this and this. So whatever that is here, the sign, we normally use sign. If you multiply it, if it's now the sign that they gave us in the equation, that becomes the answer. And formally, the answer is either this one, the joint one, or this one and this. That's this is joined by or, this last two. So let's now go back and solve. Let's go back. So now, I've told you the first is now a quadratic inequality. So we solve as if we are solving quadratic equation, which is p plus 4 minus p minus 4 equal to 0. So here p is now minus 4 or 4. These are the two answers. Now, these two answers are the ones that will give us equal to 0. So let's now get the ones that, so we'll prepare that table neatly. So we'll create our interval. This is the interval. So this is when it is, so this is the interval. So I told you it's less than, which one is the smaller one? Minus 4. Between minus 4 and 4. And finally, when it's greater than 4, yes. That's the possible interval too. So the first one is p plus 4. Second one is p minus 4. The last one is now their product. That's the determinant, what determines the answer. So let's now check. Okay. So if you pick a number, just pick a number that is less than minus 4, which is minus 5. So if you put minus 5 plus 4 will give us a negative answer. Yes. That's minus 1. Just any number that you pick within this range will always be negative. We should substitute it here. Okay, we are looking for P. We need to use P. So this should be P. Since we are looking for P, this is P. This P. This P. This P is the unknown. So if you pick, let's remember we've picked -4, -5. So -5 minus 4 is also negative. So what is negative times negative is positive. But what they gave us is what? Less than 0. So this cannot be the answer. This is off. So, and I've told you if this one is correct, this one, the last one will be correct. So the answer is that these two goes together. The two go together. The middle is down, the one just the joint inequality. So let's test the last one. So P greater than 4, let's take 5. So if you notice it's positive. 5 plus 4 is positive answer. 5 minus 4 is also positive. Positive times positive is positive. Well, what we are looking for is when it's less than negative. So this is off also. So once you test one, if it's an OBJ, you've known which one. You don't need to prepare this table, just test. But for theory, you need to make it this way. So pick a number between -4 and 4, 0. Yes, 0. 0 plus 4 is 4, so it's positive. Why 0 minus 4 is negative? Well, it's positive times negative, negative. So this is what's the answer. So the answer, the interval, therefore, the interval is now -4 less than P, and P is less than 4. So that's the actual answer. So that's how we solve a quadratic inequality. So let's move to other.
We are on sum and product of roots of a quadratic equation. You might be given a quadratic equation and you are asked to find the sum of and product of the roots. So here we're going to get a formula that will make it very simple. Instead of getting the roots individually and sum or multiply, we just use the formula. So we've known that a quadratic equation is of this form: ax squared plus b plus c equal to 0. And we know that if we solve for x by a quadratic formula, we'll have something like this. So that's our x. Remember, this is two. This can be splitted in two forms. So let's x1. We have two answers. So that's x1. Let's call it the first root, which is minus b plus and the second root, which is x subscript 2 equal minus square root b squared minus 4ac over 2a. So let's get a formula. Let's find their sum from this. Remember the title. So let's do x1 plus x2. So which is minus b plus b squared minus 4ac over 2a plus minus b minus that over 2a. So that's it, the first one. Why this is the second one? So you notice they have common denominator 2a. So we write minus b plus b squared minus 4ac plus times minus, so minus b minus square root b squared minus 4ac. And as you can see, this and this is gone. This minus this is 0. So we are left with minus 2b. That's minus b is minus 2b over 2a. So minus b over a. So what do you notice from quadratic equation? If you are given the equation, you can find the sum. So this is now sum of the roots. It's always minus b over a. That's minus the coefficient of x over the coefficient of x squared. So let's do the product. So that same way, if you now multiply, that's x1 times x2, which is minus b plus that over 2a times minus b minus square root b squared minus 4ac over 2a. So this times that is 4a squared. That's 2 times 2, 4. A times a squared. So why this minus b plus that times minus b minus this. So you can see that it's now difference of 2 square. What is here is here, what is here is here. So we can write it as minus b all squared minus square root b squared minus 4ac all squared over 4a squared. So minus b squared is b squared minus the square root affects the square. So we have minus b squared minus 4ac over 4a squared. So we have this 4a squared. B squared minus b squared is 0. So we are left with plus 4ac, so which is c over a. So what do you notice? The product of the roots is now just coefficient of, that's the constants over the coefficient of x squared. So with this you can just find, example, if you're asked to find the sum and the products of the roots of maybe 2x squared minus 4x minus 7 equal to 0. So we asked to find the sum and the product of the roots of this. So without wasting time, we say that the sum of the roots is always minus b over a, which is minus the coefficient of x, which is minus 4 over a, which is 2. So our answer is 2. So instead of wasting time solving for the roots individually, just apply this formula. Y the product is just c over a, this constant term, which is minus 7 over the coefficient of x squared, which is that. So that's our answer. So whenever you're asked to solve, just don't waste your time. Use this formula. It's very important. Thank you.
We said if p and p plus 4 are the roots of the equation, this quadratic equation, find the equation whose roots are 2p and 2p plus 8. Okay. First of all, you need to know that every quadratic equation is of the form ax squared plus bx plus c equal to 0. Yes. And the sum of the roots is minus b over a, while the product of the roots is c over a. So that's it. Also, every quadratic equation is x squared minus sum of the roots. X minus x plus product of the roots equal to 0. Yes. So every quadratic equation is also of this form. So using this knowledge, we are asked to find a quadratic equation whose roots are 2p and 2p plus 8. Therefore, we have x squared minus the sum, which is 2p plus 8. That's the sum, x, plus the product, which is 2p times 2p plus 8 is equal to 0. Yes. So I will have x squared minus, this is 4p plus 8x plus 4p squared plus 16p equal to 0. But there is nothing like that. So this is where the the first information comes in. They said p and p plus 4 are the roots of this. So now that we have p and p plus 4 are the roots of 4x squared minus 4x minus 15 equal to 0, which implies that the sum of the roots which is p plus 4 is 2p plus 4 will now be equal to minus 4 over minus 4. Should be minus 4 minus 4 over 4, making it 1. That's using this, the sum of the roots. So since p and p plus 4 are the roots, their sum will be 2p plus 4, which is minus b. B is minus 4 and a is 4. And their product, which is p times p plus 4, which is p squared plus 4p, will now be c, which is minus 15 over 4. Yes. So what do you do now? We'll come back to this. So we have 4p plus 8. So we have that. Therefore, x squared minus. So we need to write 4p plus 8 so that we'll have something like 2p plus 4. So we'll factor, for us to have 2p, so we'll have factor 2. We'll have 2p plus 4. X plus, I'm looking at this. We are using this now. If I want to bring in this plus, if we factor this p, so if we factor 4, we have p squared plus 4p equal to 0. So we substitute, we have x squared minus 2p plus 4 is 1. So 1 times x plus 4 times p squared plus 4p is minus 15 over 4 equal to 0. Therefore, our answer, the equation we are looking for, is now x squared minus 2 times 1, so that's 2x minus 2x. This is minus 15 equal to 0. So that should be option B. So that's it. So we need to know that every equation, quadratic equation, is always x squared minus sum of the roots plus product of the roots equal to 0. And it's also, the sum of the roots is always minus b. That is written a squared plus bs plus c equal to 0. The sum is minus b over n, and the product is c over a. Thank you.
Looking at this, a quadratic curve, and I'm seeing they gave us this value as 6. So meaning here should be 3. And here is minus 6. This is minus 3. So using the knowledge of the roots, so the roots are minus 6 and 3. Therefore, from here, you know that at that point y is 0, so I have 2x, or maybe 0 is equal to 2x squared plus 12 minus px minus q. So if we divide both sides by 2, so I have x squared plus 12 minus p over 2 x minus q over 2. So again, because we want to use the knowledge of our sum and product of roots. So if we negate this is now minus, okay, let's p minus 12 over 2. So I negated this. That's still correct. If you open up, we'll still get this. But I made it negative. You see why. So we'll see that, but every quadratic equation, is of the form x squared minus sum of the roots x plus product of the roots equal to 0. If you could remember this, every quadratic equation is of this form. So from here, this is a quadratic equation, meaning that this is the sum of the roots. Therefore, p minus 12 over 2 is equal to the sum of the root. The sum is minus 6 and 3. So minus 6 plus 3. And the product of the roots, which is minus q over 2, is equal to minus 6 times 3. So with that, we'll get p and q. So this 3 minus 3 times 2 is minus 6. So 12 minus 6 is 6. So p is 6. Q here is minus 18. So q is now 36. So okay, we're asked to find p plus q. So p plus q will be 6 plus that, which is 42. So it's a faster way of solving it. We can decide to substitute the values of, that's the corresponding value here. X is minus 6 and y is 0. It will form a simultaneous equation, but this is, for me, this is the fastest way. Thank you. For every quadratic equation, as squared plus bs plus equal to 0, that the sum of the roots is minus b over a, y product of roots is c over a. So from here, you see that we can rearrange this as pq minus m plus n plus r over l. Yes, I factored it. So pq is the product of roots of this, which is minus 3 over 1 minus ym plus n is the sum of the roots of this one. So we have minus 1 over minus 1. Finally, plus r and l are the y-intercept. That is, at this point, x is 0 if you substitute. So for r is minus 3. Y for L, if you substitute 0, is 1. So you see our answer will be minus 7. Option A. So on formation of quadratic equation, you might be given the roots of a quadratic equation, and you are asked to form the quadratic equation that has that root. So today we're going to derive it and know how to do it. So we've known that A quadratic equation is of this form, the general form ax squared plus bs plus c equal to 0. We've known this. We can decide to divide both sides by a. So we have a squared plus b over ax plus c over a equal to 0. And we can still write this as x squared minus b over a. So nothing has spoiled. We are still on the right track. Because I'm trying to bring in roots here. And do you remember that some of the roots of a quadratic equation, some of the roots, no need of writing, we know we are on quadratic equation. Some of the roots of any quadratic equation is minus b over a, while the product of the roots is c over a. So are you seeing something? Are you seeing? It's here. Is here. So generally, to form a quadratic equation, we now have that is always x squared minus sum of the roots times x plus product of the roots equal to 0. So yes, once you know the roots, you can form. So example, if we are asked to find the quadratic equation, quadratic equation whose roots are minus 5 and maybe 1 over 3. So without wasting time, our answer is very simple. Using this is always x squared minus sum of the root minus 5 plus 1 over 3 x plus minus 5 times 1 over 3 equal to 0. So we have x squared minus LCM 3 minus 15 plus 1 is minus 14 x plus minus 5 over 3 equal to 0. So we have x squared, LCM of the denominator, which is 3. So if you decide to multiply by 3, we have that is now 3x squared plus 14x minus 5 equal to 0. So they are the same. If the answer is not in this form, to be in this form. So that's how you solve. That's how you form a quadratic equation given the roots. Okay, but look at this technical question. So we're asked if alpha and beta are the roots of 3x squared plus 20x minus 7 equal to 0. Find the equation whose roots are this. So we are looking for the equation whose roots are alpha plus beta and alpha plus 1 over beta and beta plus 1 over. So from what we said, to form a quadratic equation is always x squared minus sum of the root is now the roots are 1 is alpha this plus beta. So this is the sum plus x, remember not to forget plus product of the roots plus the product is alpha plus 1 over that times beta plus 1 over that equal to 0. So that's this. So let's expand. We have x squared minus, which is, we know we can write this as alpha plus beta plus 1 over alpha plus 1 over beta. Yes, just nothing because plus times that, so it's not affected. We expand this times that is alpha beta plus 1 plus 1 plus 1 over alpha beta. That's this is 1, that is 1, this to this 1, that to that. Okay, equal to 0. So we have x squared minus, we can sum this alpha plus beta. We can sum this as alpha beta, that's the addition of this, which is alpha plus beta, plus this is alpha beta plus 2, or maybe let's write 1 over alpha beta plus 2 equal to 0. So this is where, because we need to get this sum, this and the product. Remember they said alpha and beta are the roots of this. Remember, that's what they said. Alpha and beta are the roots of that. So meaning that the sum of their roots, using our sum formula for roots, is minus 20 over 3. Yes. While their product is minus 7 over 3. So we need to substitute this here. So do you see the logic? They told us this and this are the roots of that. So the sum is using our formula minus b over a, minus 20 over 3. So let's substitute. We have x squared minus alpha plus beta is minus 20 over 3 plus alpha plus beta is that. So this over this. So maybe let's do it here. Alpha plus beta over alpha beta is this over this, which is 20 over 7. So this is 20 over 7 plus alpha beta is minus, okay, let's put this in bracket, minus 7 over 3 minus 7 over 3. Why this plus that? So if you reciprocate, so it's now minus 3 over 7. Do you get? Just reciprocal. Plus 2 equal to 0. Okay, let's continue. We have, okay, what you notice, the LCM of all this. So if you multiply each by the LCM of 3 and 7 is 21. So we have 21x squared minus 21 times that is minus 140. 21 times that is plus 60 x plus 21 times that is minus 49. 21 times that is minus 9. 21 times that is 42. So I did it to clear the fractions. So 21 7. Okay, we have 21x squared minus 140 plus 60 is minus 80. So minus times minus plus 80x plus, you get this plus that is minus 80. So minus 80 times minus here. So y minus 49 minus 49 plus that is minus 7. Minus 7 minus 9 is minus 16. So I have minus 16. Equal to 0. So that's our answer. That's the equation. So while solving such question, you need to be very careful. So we are asked the sum of a number and its reciprocal is 65 over 8. We are asked to find the number. Okay. So let the number be x. Then they told us that x plus 1 over x is 65 over 8. So we have to solve, we have to find the numbers x. So we have the LCM of 1, x and 8 is 8x. So multiplying each by 8x, I have 8x squared plus 8 equal to 65x. So I did it to clear the fraction. So moving everything to one side, I have 8x squared minus 65x plus 8 equal to 0. So we form a quadratic equation which could be factored as 8x minus 1 and x minus 8. Yes. If you open up this, we'll get back this. So the product of two numbers to be 0 means that one of them must be 0. So either this is 0 or s minus 8 is 0. Which implies that the numbers are x equal to 1 over 8 or 8. So anyone could solve. So that's the answer. The next one, the sum of two numbers is 13 and the sum of the squares of the number is that. We have to find the difference of the numbers. So solution, so let the numbers be x and y. Then the sum of the two numbers, that's x plus y equals 13. And the sum of the squares, that is x squared plus y squared equal to 85. So looking at this addition of two squares, so it could be written as x plus y all squared minus 2xy equal to 85. Yes, it's called addition of two squares. And we are given that x plus y is 13, so I have 13 squared minus 2xy equals 85. So this goes over to here to be 2xy. Why this comes here to be this 13 squared is 169 minus 85. So we have 2xy, xy equal to 84. So we have xy equal to 42. So which implies that x is 42 over y. So call it equation 2. So substituting this value in equation 1. So wherever I see x, call it 42 over y. So I have 42 over y plus y equals 13. So clearing the fraction again, that's the denominator, multiply by y. So I have 42 plus, as each of them I will multiply by y. 42 plus y squared equals 13y. So moving everything to one side, so we move this to this side, we have y squared minus 13y plus 40 equal to 0. And we can factor this as y minus 6 and y minus 7. Yes, 4 to 0. Or if you open up this, you get this. So for the two numbers, the product to be 0 means that one of them must be 0 or y minus 7 is 0. So we have that y is either 6 or 7. So when y is 6, therefore x is 42 over 6. When y is 7, x is 42 over 7. So x is either 7 or 6. But we have to find the difference. So when x is 7, y is 6, therefore the difference is 7 minus 6, which is 1. So anyone could solve. So thank you. The shortest side of a right triangle is 2 cm shorter than its hypotenuse. The difference in length of the legs is 1 cm. Find the perimeter. Okay. So let the shortest side be x. Then the remaining remember they say the difference between this, so it should be x plus 1 and s plus 2, because they say the difference between the shortest side and the longest side is 2 cm. So this minus this is 2, why this minus this is 1. Therefore, so we apply Pythagorean theorem here, which is x squared plus x plus 1 squared must give us s plus 2 squared. Yes, by Pythagorean theorem. So okay, let's write Pythagorean theorem. Because it's a right angle triangle. So we have x squared plus, expanding this, we have x squared plus 2x plus 1 equals, expanding this, we have x squared plus 4x plus 4. So we have 2, we have 1, 1, so we are left with 1, which is x squared plus, you get, this is gone, so we are left with this. So this comes over to be 2x minus 4x is minus x, so this should be minus should be minus 2x. So this is gone. So 1 minus 4 is minus 3 equal to 0. So we'll write this in factored form, which is x minus 1 s plus 1 times x minus 3. Yes, if you open up this, we'll get this. So the product of two numbers to be 0 implies that this is 0 or x minus 3 is 0. So I have x is minus 1 or x is 3. So they said, remember, we're asked to find the perimeter, but we know length can be negative, so this is off. So this is the one we choose. So perimeter, therefore the perimeter is the addition of the side, which is x plus 1 plus x plus 2, which is 3. This s plus x is 3x plus 3. So which is 3 times 3 plus 3. So this is 9. So the answer is 9 plus 3 is 12. So our perimeter is 12. So they say the base length of a triangle is 1 cm more than the height. Then the area is 6 cm. Find the perimeter. Okay, we are given the base. So let's the base be x. Then the height, they say the base is 1 cm more than the height. The height is x minus 1. Yes, since the base is 1 cm more than the height. So therefore, remember, area of a triangle is half base times height. Half base times height. So we substitute. They gave us the area is 6. Half the base is x. The height is x minus 1. So I have 12. I'm cross multiplying 12. Why this is x times x minus 1. So open up the bracket. I have x squared minus x. This times that gives us this equal to 12. But we have to bring the 12 to that side to be minus 12 equal to 0. So we'll factor. So we have minus 4, s minus 4, and s plus 3. Yes. If you open up this, we'll get this. Therefore, the product of two numbers to be 0 means that one of them must be 0. So either the first one is 0 or the second one is 0. So we have x is 4 or x is minus 3. But remember, we're asked to find the perimeter, but we are not given the third side. But common sense will tell us that since area is half base times height, We know that area is half base, the base, because we won't take this, it can be negative. Half base times the height is 3, x minus 1, which is 6. Implies that this is a right angle triangle. Yes. For the area to be half base times, that's if you multiply half, if you substitute the value of base and height, it gave us 6. So it must be a right angle triangle. So the hypotenuse, therefore the hypotenuse is 5 by Pythagorean theorem. Yes. So therefore the perimeter is now 4 plus 3 plus 5, which is this 12. So that's the answer. They say two cyclists move away from a town along two perpendicular paths at 20 km per hour and 40 km per hour. If the second cyclist starts the journey 60 minutes later than the first one, find the time taken for them to be 100 kilometers apart. So seeing kilometer means the distance. So the first thing we said, let the time for the first cyclist be t, then the second starts 1 hour. Remember the time is in 1 hour, so we convert 60 minutes to hour, which is 1 hour. So the second one starts 1 hour late, so then the second is t minus 1. Do you get the logic? Is 1 hour late. So from here we need to convert this speed, because this is speed, to distance. We know that distance is always speed times time. So for the first cyclist d1, the distance is 20 times t, which is 20t, while the second one d2 is 40 times t minus 1. So we've converted it to distance because they gave us the distance apart. Remember, they said they started here. So this first one moved, maybe this one moved up to be 20t, while the second moved to the other direction, which is 40t minus 1. 100 kilometers apart. So we'll form a right triangle with that. So applying Pythagorean theorem, we know that 20t squared plus 40t minus 1 all squared will be equal to 100 squared. Yes, by Pythagorean theorem. So let's expand. We have 20 squared is 400. So we have 400t squared plus 40 squared is 1600. So 16t minus 1 squared equal to 100 squared is 10 raised to the power 4. So dividing both sides by 100, because I can see they have common term 100. So dividing both sides by 100, I have 4t squared plus 16t minus 1 squared equal to 100. Again, it seems something can still go. We can divide by 4. So dividing both sides by 4, I have t squared plus 4t minus 1 squared equal to 25. So I divided both sides by 4 after I have divided by 100. So we'll open up this. We have t squared plus 4t squared minus 2t plus 1 equal to 25. So open up this. T squared plus 4t squared is 5t squared minus that 4 times minus 2t is minus 8t. This times that is plus 4 equal to 25. So we have 5t squared minus 8t. This comes here to be minus, so 4 minus 25 is minus 21 equal to 0. So we form a quadratic equation. So we can solve this by factorization. We have is 5t plus 7 times t minus this 20, so minus 3. If you open up this, that's what you get. 7t minus 15, so minus 8. Okay, we are correct, equal to 0. And the product of two numbers to be 0 means that one must be 0. So either the first one is 0 or the second one, which is minus 3, equal to 0. So we now have that the time is 3. We'll discard this because the time here will be negative. We'll get t equal to minus 7 over 5. So no need of using it. This is off because it's negative. Time is always positive. So to find the time taken for them to be 100 kilometers apart, the time is 3. So t is 3. So that's our answer. 3 hours. So thank you.